Okay, let us discuss about the designing of symmetrical T-attenuator. So you can see here there are two series arm resistances and one shunt arm resistance, which is R2, and series arm resistances are R1, which are equal because it is symmetrical T type, right? So for this T-attenuator, since it is symmetrical, the terminated resistance is R0. When that is R0, the input resistance will also be R0, that you can see here, right? So for this case we need to design the T-attenuator. Designing of T-attenuator means we need to obtain the expressions for R1 as well as R2, but in terms of what? In terms of R0, that is characteristic resistance, as well as the attenuation required, which will be coming in dBs or capital N. If you know capital N, you can even get the alpha, right? We have seen in the introduction class to the attenuator. So fine, now you will be given with the required attenuation as well as the characteristic resistance. Of course, this characteristic resistance is nothing but load resistance or terminating resistance. Okay, once those two are given, you need to determine the values of R1 as well as R2. Let us see how we are going to determine them. So first we need to get the ratio of I1 by I2. In order to get the ratio of I1 by I2, we are going to apply KVL in loop 2. Okay, so what happens when you apply KVL? How many resistors are there in this loop 2? 1, 2, 3. So R2 into I2 minus I1 plus I2 into R1 plus R0 is equal to 0. Right? I have added these two resistors here. The current flowing through R1 and R0 is I2, whereas the current flowing from down to the up in R2 is I2 minus I1. Then you will get this equation. And then get the ratio of I1 by I2. From that equation, you will be getting capital N I1 by I2 is equal to R1 plus R2 plus R0 divided by R2. Consider this as equation number 1. Okay, then we need to have R0 equivalent resistance, that is source resistance, which will be obtained from the connections of these resistors. R0 and R1 are in series, and that combination is in parallel with R2, and then overall combination is in series with R1, right? Then you will be getting R1 plus R2 into R1 plus R0 by R1 plus R0 plus R2. Consider this as equation number 2. Okay, now when you substitute 1, that is I1 by I2, into, you can write it directly like R0 is equal to R1 plus R0 by N, because N is nothing but R1 plus R2 plus R0 by R2. So you can directly substitute this here, right? Okay, then when you cross multiply, you will be getting this relationship from which you can get R1 value, right? What is the R1? It is in terms of R0 and capital N. As I said, you will be given these values, capital N and R0. Otherwise, from the given attenuation, you can determine capital N, and then you can design the value of resistance R1. Then in order to get R2, you have to substitute this R1 in equation number 1. Okay, what is that? You will get NR2, that is N into R2 is equal to R1 plus R2 plus R0, right? And here in place of R1, you have substituted equation number 3, that is this, and plus R2 plus R0 is there. So when you solve all these, you will be getting R2 as well. Okay, so this is what the designing of symmetrical T-attenuator is. Okay, very important equations. Mostly you will be asked with the numerical problems to design a particular attenuator for the given characteristic resistance as well as attenuation. Okay, that's it